Hello, and welcome to 5-Minute Math. Today we are looking at the fourth grade concept of measurement problems. This is standard 4.8C, readiness practice, the intermediate version. If you are interested in exploring the proficient or advanced versions of 4.8C or the readiness practice resources aligned with any other standard, you can find those by using the link in the video description. So our first problem has to do with money. So we're paying for lunch. After lunch, paying for lunch. John has 3/4, so let's just draw 3/4. 2 nickels and 1 dime, so we'll put a dime, we'll put 2 nickels. And then he paid with a $5 bill. How much did his lunch cost? All right, so let's put some money on this. So this is 25, 25, 25. That's 75 cents here. This is 10 cents here. And then I've got a 5 and a 10, another 10 cents. All right, so if I add all this up, I'm at 75, 85, 95. Now this is 95 cents. So let's go ahead and put that decimal there. That's going to be helpful. So that's how much money he has left after paying for lunch. He paid with a $5 bill. So if I want to figure out how much money the actual lunch cost, I'm going to take what he originally had at $5, and I'm going to subtract how much he actually has left, that 95 cents. And one way to think of it like this would be as a strip diagram. Think of it like this as a part whole. Right, so here's my 95 cents. What I'm missing is how much his lunch actually cost. So now we need to take a dollar, leaving 4. I've got 10 dimes. Take a dime, leaving 9. Now I've got 10 pennies. That's 5, 0, $4.05. All right, so that makes sense. That missing amount is $4.05. So we can say his lunch cost, and then we'll put our amount, $4.05. All right, for our second problem, it's a time interval problem. So we're going to start movie at 7:15 and 9:08. Now, there's a few different ways to solve this. I like to solve it using a number line like this. Okay, so I'm going to start at 7:15. What I want to do is I want to take big hour-long jumps if I can. So 1 hour is going to be 8:15. Now, if I take another hour jump, I'm at 9:15, and I'm past that 9:08. So now I can't take hour-long jumps. I have to take minute jumps. So I'm going to take 10-minute jumps. So 10 minutes is going to get me to 8:25. 10 minutes is going to get me to 8:35. I'm going to just kind of inch my way up. So 8:55. Okay. So now I am, if I could do this, if I could take a little tiny jump right here, 5 minutes, guess what this gets me to? 9 o'clock. If I can get to 9 o'clock, the next jump is going to be pretty easy. I'm just going to do an 8-minute jump, and now I'm at 9:08, which is where I need to go. So really what I need to do now is just add all of these chunks. So let's add my minutes here to make sure that this is less than 60 minutes. If this is more than 60 minutes, I need to convert this to an hour. So I've got 10, 10, 10, 10, a 5, and an 8. All right, 4 tens, a 5, and an 8. So that's 13. And that's 1, 2, 3, 4, 5. Okay, 53 minutes. So we can say the movie was, and then we can put our time together. 1 hour. Typically, you just put them together like this. 1 with an HR, and then 53 MIN. Sometimes people can kind of do it like this, but then that can be confusing as to whether you're thinking hours and minutes or actually, that time, 1:53 a.m. or p.m. And so probably we'll do the 1 hour 53 minutes in that top version. So For our third problem, we have to convert units of measure. So we have a ribbon that is 5 feet long. All right, so that's going to be our hole. And then if we cut off 2 feet 3 inches, how much ribbon is left? All right, well, if I cut off 2 feet 3 inches, that's one part. What's my other part? Now, here's my problem, is you can't really subtract it like this, because this is what it would look like if we wanted to subtract. You can, you just have to think about it slightly different. So if this is my feet, this is my inches, almost think of it like a mixed number with a fraction, okay? So I've got 5 feet 0 inches minus 2 feet 3 inches. I'm going to draw a line to kind of separate these two here. Now, here's the thing. If you borrow from this 5, you can. You can reimagine one of those 5 inches. But a foot, 5 feet, the foot is not equal to 10. When we borrow, typically we do 10. A foot is actually 12 inches. So we need to reimagine that foot that we took as a 12 inches. Just think about it. We've got 5 feet. If these are all feet, right? 1 foot, 1 foot, 1 foot, 1 foot, and then here's 1 foot. We know that 1 foot equals 12 inches, so I'm going to take this foot right here, and I'm just going to rename it as 12 inches. That leaves me with 4 feet and 12 inches. If you could do that, now that's pretty simple. We've got 9 inches, and we've got 2 feet. So we can say there is 2 feet 9 inches left. What we need to do if we want to subtract is we just can't always think of it as a base 10. We need to think of the units of measurement. In this case, they're 12 inches in 1 foot. If you are interested in exploring the 4.8C readiness practice for the proficient or advanced versions, or the readiness practice resources aligned with any other standard, you can find those by using the link in the video description.